Add him.
Sir?
Absolutely, sir.
Have fun, huh?
Yo,
We are here.
hi, baby, at Madam Louisa.
You're fine. You're fine. Thank you.
said I was trying to do it but shortly, but I hope you've not all been able to download the Tableau, the app on our system. Am I audible? Can you hear me?
I can hear you, but you're not really audible.
Oh, okay. I was asking if you've been able to download Tableau on our system.
Yes, I do. We downloaded that time in class, but now it's telling me that the version of my Tableau public is no longer supported.
Okay.
So it said I should click the link to download the latest version. I've done it, but it's not showing me where to download or to update. So I don't know.
Anyone else having issues downloading or we've been able to download?
Say that again.
I'm asking if anyone else is having a similar issue or we've all been able to download it. Anyway.
Hello.
Doctor, good afternoon.
Yeah, good afternoon. I hope you guys can hear me well.
Yes, sir.
My network is giving me problems. Okay, what's up now?
Welcome.
All right. Good afternoon, everyone.
Good afternoon, Dr. Francis.
Yeah, good afternoon. All right, so where did we stop last? Where did we stop in the last session?
We're rounding up R. We had done regression, we had done math.
So we have done what?
In R, we had done maps. We had gotten to maps and regression in R.
Okay, we did the visualization, right? Okay, we said we'll wrap up the remaining ones. The remaining, what they call it now? Algorithms, have you?
Yes.
Okay. Which data set did we use? Which data set did we use? Okay, let me look for anyone that. Look for the one that will be easy for us to use. There was one that we used there. Is it a social networking data?
Or it was OLS, and OLS and social network ads.
Yes, that okay. Can you share that social network for me? The one that has purchase, right? I think it had purchase and some other things there. But that. So who has to share? Let us start. Okay, I think I've seen social network adverts, isn't it?
Yes. Ads.
Yes, ads. Okay, I've seen it here. So let me see my desktop. Is somebody sharing it on the group on the chats? Or let me see if I can share it.
Yeah, I'll share it on the day club.
Aha, all right. Okay, I've shared it again. Okay, that's all right. Let me share my screen. So you know when we are dealing with machine learning, right? We are dealing with machine learning, right? We are trying to understand the patterns in the data. Okay, we're trying to understand the patterns in the data. Okay, and basically under machine learning, we can group them into two, right? What are the two classes of machine learning algorithms? What are the two classes of? You have what?
Supervised and unsupervised.
Yes, supervised machine learning, and what? Unsupervised, right? So when we say supervised, what do you understand by supervised? When you say it's a supervised machine learning algorithm, what do you mean by that?
Meaning that we tell this load what we want to feed in.
The target variable is none.
We what?
The target variable is none.
Yes, the target variable is known. So remember that y is a function of x, is it not? So if, for example, this is advertising and this is sales, isn't it? Here, where this variable here is known, it's known as supervised, right? So it can be either of two parts. Either the data is what? A numerical data, is it not? Or it is categorical. Is it not? So if it is numeric, what algorithm do we use?
Linear.
We use what? Your linear regression, isn't it? But if it is categorical, which algorithm do we use?
I use your logistic.
You can use logistic. Yes. Which other one can you use?
I use k nearest neighbor. KNN.
Yes, KNN. You can use K nearest neighbor. Which other one can you use?
Support vector machine.
Yes, SVM. Yes, you can use SVM. And also you can use Bayes, naive Bayes, right? So if you remember your Bayes theorem, naive Bayes. Okay. So these are the basic ones. We'll try and see how we can implement it with R. Because remember our no free lunch theorem, right? What does it say? No free lunch theorem. What does it say?
No one algorithm is one size fits all.
No one algorithm is it not? So you look for the one which is the best, is it not? And pick. Okay. Because no one particular algorithm will suit every situation. But you just need to understand the criteria for using any of these ones. Okay, so usually they are used for what? They are classifiers. They're usually called classifiers. So let's see how we can implement them. Okay. Because I'm sure for regression, we should be okay with regression because we have done both simple regression, is it not? And we have done multiple regression, isn't it? Because at the back end of every of these machine learning algorithm is your normal regression. Okay, only as the data starts changing and the conditions start changing, you need to also change the kind of data that you have. Okay, so now the first thing we need to do is to import the data, isn't it? So we need to import the data. So how do we import the data?
Let's get the libraries.
First, bring the libraries. What are the libraries we need?
Tidyverse.
So let us import what? The data sets. So you can bring in what? Library. Which library?
Tidyverse.
So maybe tidyverse. Okay, let's say tidyverse. If I run tidyverse like this, you see it will not allow me. So I have to put it tidyverse. Say no package called tidyverse. So what's the problem there?
Spelling of the verse.
Tidy what? Verse, exactly. All right, still saying no tidyverse. Spelling correct? Does it work now? All right, so you just check. So if you have not installed your own, make sure that it's installed. Okay, it's working there. So which other library? Deep layer. Which other library?
ggplot.
ggplot, exactly. So if you want to plot any chart, you can use what? The ggplot. Okay, we can use what? The ggplot. Now, but again, when you want to import the data again, what's the data type? What kind of data do we have? Is it a CSV file, an Excel file?
Yes.
It's a CSV file, isn't it? So you know normally how you copy your data, isn't it? You copy the parts from your data. You go to the maybe if it's in your desktop or wherever it is. right? Then you look for where the data is, and from there, you can now import it. Let me see where mine is. Let me see. Okay, mine is on my desktop here. So let me put it on the desktop. So let me share my desktop. Oh, I can't even show my desktop. Screen. Is my desktop showing?
Yes.
Can you see my desk?
Yes.
So look at this. So for example, you know how normally we would have gone through to copy the path. If I right click on it, you will see that if I want to copy the path, I usually go to the folder, isn't it? To look for the paths. But another easy way of doing it, right? How do we do it? Hold your shift button. Hold your shift button, right? When you hold your shift button and right click, can you see copy as paths? Look
Yes.
at it. You know, when I press right click, there's nothing like copy as paths here. Can you see there's nothing like copy as paths here? If I hold my shift button and I come and right click on the file, can you see now copy as paths? So instead of navigating through your, what they call it, through your internet, through your Explorer, right? You can just come there and say copy as paths. So once you copy as paths, this. Once you hold your shift button, that copy as path will come out. Okay. So, but again, you need to bring the library. Which library is that? Read words R, is it not? If it was an Excel file, it would be read Excel. For this, read. So let's call it data sets. Data set. So what will I call it now? Data set. What next?
Read .csv.
That's
read CSV. Read.csv.
Yes, read CSV, exactly. Then I'll now copy the part there. Right? But remember, we cannot use this, isn't it? Rather, we now switch it to what? A forward slash. Another way again, you can also do this. Instead of you always copying this start, right? And that thing again you can do, for example, if I create a folder, so let me share my screen again. Because now that we are familiar with R a bit, I think I can now show you some things. Okay, let me share screen. Okay, now let me create a folder. Let me call it R data sets. Now, can you see my R data sets? Now, this is a folder. Yeah, so let me copy this and paste it here. So now my data set is inside Arrow data set, isn't it? It's inside Arrow data sets. Okay. So what you normally do is that so that you don't start copying your data every time. Okay. So what you will normally do is to set your directory. So if I come here, so what you can do is to set your directory. So how do we do that? So if I come to my session, can you see session? Can you see set working directory? Can you see that?
Yes,
set
sir.
working directory. Then I'll have to go to choose directory. So I'll go to my desktop. Can you see my R data sets? I'll say open. So I've set my directory now. Okay. So this is the name of the file now, isn't it? So now if I call data sets, and I say read.csv, the only thing I'll just do is to type the name now. What's the name? Social network ads.csv. Can you see now it has worked? So which of the method do you prefer?
This one.
So if I set the directory, that means I will only copy the file to that directory and just call the name of the file. But otherwise, you will now have to come and copy this and now change it to the backslash. Can you see that? So either of the methods you can also use. But this is the one, once we are, because we are still learning, that's why I taught this particular method. But this is actually a better way of doing it. Is that all right?
Yes.
Okay, good. Now, whenever you are doing classification now, apart from these other libraries, there's another library again we need to bring in. Library is called CA tools, like classification tools, right? So you have to bring that library also. But if yours is not installed, so you know how to install your packages. So install.packages, they call it CA tools. Now take note of CA, right? Then the tools, capital letter. So if I come here and say CA tools, so let's read what CA tools is about. So can you see that? So all those your classifiers that you are going to be having, most of them, they are inside this package. Can you see that? Your logistic regression, KNN, they'll all be part of this thing here. Okay, so whenever you don't remember, they just come and look for where the syntax is, copy it and go and paste and start using it. So that's another library that we also need. Okay, that's another library we also need. All right, so we have seen how to bring in the data now, right? So let's look at the data sets now. Let's look at data sets. Data sets. So let me view. Now, can you see the data set now?
Yeah.
Can you see the data set now? So let's say, for example, now for this data set now, all I need is maybe just these last 3 columns, right? Because you know this one, gender, user ID, most times if you are not taking it as a particular variable, then because all my variables need to be quantitative, is it not? In case it is categorical, for example, purchase means 0 means did not purchase, 1 means purchased. So if you see purchase, did not purchase, did not purchase, you have to now convert it into 0 and 1, right? So that's when you do your data pre-processing to clean it up. But you must make sure that all your data, they are in what? This quantitative form first, right? So here, we don't need all the columns. I just need from column 3 to 5, is it not? Column 1, 2, 3, 4, 5. So I need from column 3 to 5. So this data set I will need. But in a more practical cases, you actually need larger data set in terms of the features that you are going to use. All right, so what we are going to do, I'll just call data sets. So data set, remember, I want to call it from where? From 3 to 5, isn't it? So I've assigned it. This data set, I want to select from column 3 to 5. So look at it, data set 3 to 5. Can you see that now? It has selected the 3 to 5. But if I want to see it, let me view. View data set 3 to 5. Can you see it now? Age estimate. I'm sure we are clear with this one. We already used to this already now.
Yeah.
Isn't it? Good. Now, you know, most times what we want to also do is that once we get our data set now, most times what we try to do is to split the data set. Is it not? We want to split the data set. We'll split it into what? What are we splitting it into? Train and what? Test sets. Train and test sets. Train and test set. Okay, good. I hope everybody understand what we are doing here.
Yes,
You
sir.
understand what is going on here? Because what we have been doing in the past already, isn't it? So the same way. Now remember again that if you want to ensure that we have the same data set, because sometimes when you want to split your data, it has to split it randomly. Okay, so if you want to ensure that we have the same data set, then you don't need to set seed. So that set seed means I want to select the data set, but we'll have the same sample. Okay, so I can set any amount. I can set seed 100. I can set seed 123, 150, 200. So set seed means just set it so that when it's picking it randomly, we'll pick exactly the same data. Okay, but if you don't want it, then you just pick it randomly the way it wants. All right. Now, the next thing you want to do is to split your data, isn't it? You want to split it into what? The train test and what? The test set. Okay. We'll split it into what? The train and what? The tests. So train set, test set. So when we want to split it now, what do we do? So we can say, for example, so let me call it split. What am I splitting? So I'll say sample.split. Can you see sample.split? Now, remember that if we look at the data, y as a function of x, right? But we have like two variables there. My y, what is my y? What is my y in this case?
Purchase.
Purchase, is it not? So it will be purchased as a function of what are the variables?
Age.
Eh?
Age.
Age.
Gender.
I don't think it's
Did we use gender?
Okay. Salary.
Salary, estimated salary, is it not? And salary. So you see, when you think about the model you want to build, right? What are those factors that will influence you towards purchase on the website? So they are looking at age and they're looking at salary. Okay. You may have other features, but if are the only features you want, then that's fine. Now, the next thing you need to do is to look for how to measure them, isn't it? Once you measure it, it means how do I measure it to get the data? So now you have gotten what? The data, isn't it? So I want to break it into two parts. The train. So all this is my y, all this will be my x, right? So this will be my train, and I will have my test. The same thing will happen here. You have your train, and you have your test. So train is the one your model will see. Test, your data will not see it. Okay? Train, you will see, your model will see it, but test, your model will not see it. Then you now try to predict it, whether it will give you this result or not. Okay? You now try to do what? The prediction. Okay, so let's go. I hope this is clear now. So is that train and test we are trying to break into train and test. So I want to split it into train and test. So let's see how we are doing it. So sample.split, isn't it? Now I have to call the y. So data sets purchased, isn't it? Purchased. Okay. So I want to split my target variable. Then what's the split ratio? Split ratio, you know, when you are splitting it, you can either split it either 80%, 80-20, some can be 30-20, 20-30, some can be 75-25. Which one do we prefer?
80-20.
80-20. So if you want to use 80-20, you now set, I want 80%, so 0.8. Okay. So what we have done there is to what? Split it. Okay. But now you see, once you have split the data, I need to now separate them. Let me say split. Can you see what it's doing there? True, false, true, false, true, false. So it's just going through it for you. Okay. Now, once I have split the data there, let me separate it into its training set and test sets. So if it has been splitted true, if it's not splitted false. Okay. So I want to break it into train and test. So train. So let's say training sets. Okay. You can use subsets So subset now of my data set. Subsets, right? Now that split, remember this split that we have done here, is it not? So we want where it is what? True. Where it is what? True. So we select only the ones that are true. Why for your training sets? So for your test set now will be what? Test set will be subset data where split is equals to what now? Where split is what?
False.
False. Okay, so now we have broken it into train test. So that first split we have done, if you split it into one to give it true, otherwise false, true, false. So true will be for your training set, false will be for your test set. All right. So now if I check training sets, can you see the data now? It has picked them randomly now. It has picked them for you now. So I've broken it down for you into your train test. Then the same thing with your test sets. Okay. So if I run my test sets, train sets. Okay. Good. Now, what's the next thing we'll do now? What's the next thing to do?
Bring in a model.
Yeah?
We bring in the model.
The model. Okay, sometimes you can do your classification, but another thing again is good to do is to scale it. So they call it feature scaling. That means you see that this is in thousands, but this is in what? In units, right? In just a single unit, single digit. This is double digit. This is like how many digits? Like 5 digits, right? This is single digit. So you see, they are not all on the same level. So we need to scale them to bring them to the same level. Okay. So what do I want to do? I want to scale these first two, this and this. Okay. So for my training sets, I want to select from the first to the second. Right? So what do I want to do? I want to scale it. Okay, to scale. So training sets, I want to scale everything. Remember, if I put this comma 1 to 2, what does this mean? What does this mean? Comma 1 to 2. What does it mean?
All the rows and just the first two columns.
Yeah?
All the rows with the first two columns.
Yes, all the rows and what? The first two columns. So if we remember, if we look at our data sets, so let me look at the data sets. So if I say view, can you see data sets? This is all the columns. So if I want to pick maybe this last two, I want to pick this last two. How will I pick this last two? So this is 1, 2, 3, 4, 5, is it not? So I'll call it what? Data sets. Is that 4 to 5?
Yes.
So can you see that 4 to 5, I've picked that last two. Which means if I want to pick my first two, how will I do that? It will be 1 to what? 2. Means give me the first two data. So can you see the first two data sets? 1, 2. So that is exactly what we have done here. So that's what we have done here. If I have -5, what does -5 do? -5, what will it do?
That counting from the red.
-5, what will it do?
From the last column down to the first.
You know, this is not Python. Python does negative indexing.
Oh, okay.
But R -5 means remove the last column. You remember that? -5 means remove the last column. So that's why in this column now, you can no longer see that purchase there. So if I say -1, -1 means what now? If I say -1 means what now? remove what? The first column. Can you see that? Remove the first column. Okay. So those are the way you pick your data. All right, good. So now we have scaled the first one, so we can now scale it. Must be numeric. What have I run this one before?
No.
Say X must be numeric. Which one is not numeric? Okay, let me run it again and see. So I've done it this way. Onwards, unidentified columns. This has changed somewhere. Okay, sorry. Let me just bring it back again. View my data set. Okay, good. All right, good. So data sets. So let me see. Unidentified columns. I hope I didn't remove anything, all right? View data sets. 1, 2, 3. So I have my 3 columns there now. So let me take that. All right. So if I say view data sets, unidentified column selected. Unidentified column. Okay, you know why it's giving me error?
You've already assigned it 3 to
Because
5.
I had already removed it exactly. I had already removed it. So if I want to view it, it will be view data sets, isn't it? It will be view data sets. So now that's the data set, isn't it? Good. So we say we set seeds. Okay, split 80%. But if you want 75%, you put 0.75 there. Train test. So this is train. This is test. Features. Yes.
Can you explain that set seed again?
That what?
Set seed.
Okay, set seed. You know, sometimes, you know, when you are picking, when you are going to pick your samples, it's going to pick it randomly. Right? Since it's going to pick it randomly, right? It doesn't mean pick 100 data sets. It just means that at this code, 1, 2, 3, if you run it and I run my own, we should have the same data sets.
Oh, okay.
So it's just like saying if I say pick 1 to 10, 1, 2, 3, 4, 5, 6, 7, okay, let's say 7, 8, 9, 10, is it not? So if I say set seeds, let's say set seeds, let's say set seed 1, right? Set seed 1. It means that from this one, if you put set seed 1, right? If, for example, from that set seed 1, the random number is going to pick is 5. If you run your own, the same set seed 1, you should get 5 also. Do you get? If I have said set seed 10, if I have got maybe 9 in my own case, when you run your using set seed 10, you also get 9. But if you don't set seed, it will pick any random number. It can pick any number between 1 to 10. But just to ensure that we have the same data set, so that's why they use set seed. In Python, what do we call it in Python? In Python, what did we call it?
This size is the other one.
Huh?
Trying to remember.
Python, I think it was still seed. Was it seed?
No, it's not seed.
It's not seed.
Random.
So for
Random.
no, for let's say for Python now, you use train test split, is it not? Train test split, then what again? Train test split, then what again?
Test size.
Test size, yes.
And
Train test size, then there will not be something that will not pick there.
Random number, random something.
Random number. Was it random number?
I think it was random something, or random sample.
Yeah, something like that, Sharp. No, I can't even remember the syntax again. Or if you have, was it sample? No, it's not, I'm not sure it's sample.
I think random states.
Random state. Thank you very much. Random state, exactly. So random state and set seed, they are the same thing. That random state and test seed, they are the same thing. Okay. Okay, see now it has worked now, right? So let's do the same. So let's also scale. Anything you do for the train set, you must do for the test set. So we want to do the test sets. We want to scale for the test sets. All right, so we have scaled for the test set, isn't it? Now the next thing we want to do is to fit the regression, isn't it? So fit. So if it's for logistics, you say fit logistic regression. Fit the logistic regression. Now for the logistic regression, now let's call it classifier. Let's say classifier. Okay. So for the classifier now, what it normally is uses the generalized linear model, GLM. For OLF, if you're running a regression, what's the classifier it uses? For regression, which method does it use? For regression, what does it use?
LM.
LM, exactly, use linear model. But this use generalized linear model. Okay. So you now have to call it. So here, you remember the formula. You now have formula. If you don't remember what to do there, just put question mark GLM. GLM. Question mark GLM. So can you see the generalized linear models? So you now see, can you see everything? Now, in case you don't remember it, can you see that? So these are all the syntax that you need to put there. Okay, so that you use this method or you use this method. Okay. All right, good. So we'll start with the formula now, right? So what's the formula? So what's the dependent variable? Remember, you must start with your y as a function of what? X1, X2, X3. So in this case, what is our y?
Case.
Our y is what?
Okay.
Yes, our y is what? Purchased, is it not? Purchased. Followed by this one. So y will be what? Purchased. Remember, it is very case sensitive. So take note. This capital letter P, because if I go and put small letter P now, lowercase, error. Okay. So next thing I'll do is to what? Then I'll call the remaining variables. So if they were plenty, I'll just put full stop there. I hope you remember that. So it means give me everything there. Everything else. Okay. So that's full stop, comma. Now, what's the family now? So the family, right? The family now. What methods are we using now? So say family, we are using what? Binomial. Binomial. So that's the family there, binomial. Then the data, which data set are we using? We are using what? The training set. Is it not? Training what sets? And we use the training set. In case it's not clear, let me just bring it down here so we can read it. Is it okay? Is it okay like this, or you prefer it on the straight line? Which one do you prefer?
I think it's okay like this.
Yeah?
I think it's okay like this.
It's okay like this. Okay, that's fine. So now when I want to run it, so classifier, isn't it? So I will run it. Okay. Now if I come here to classifier, and run it. Now you see it has run that your regression for me. Can you see that? It has run the regression. But take note, logistic regression is not exactly like your linear regression. The problem is that you know your normal regression, this is your y, right? As a function of x. For your OLS, that is your linear model, it's not. This is your linear model. You know the assumption that this value is random. Is a random variable. It means it should be any value. Right? It should be any value. But in regression, in this case now, this our y is not taking any value. It lies between what? 0 and what? 1. Can we see that? So that is why when you plot the chart, if I have 0 here, I have 1 here. So it goes something like this. Can you see that? Like an S shape. So that means it's going between 0 and 1. So that is why it has moved from a what? Least square method to what they call maximum likelihood method. So that's why it has now moved to what? A probability. So probability of it happened between 0 and what? But remember, the probability lies between 0 and what? 1. And for logistic, this binary means it has only 2 possible outcomes between 0 and what? 1. Okay, so that's why it's a bit different when you are what? Interpreting it. Okay, did anybody just join us today?
Some people came to, because we felt that we're going to start Tableau today. So
Well, are we starting? Is it today we say we are starting Tableau? I think we are ending this today with so that next is it for the next month that we are starting with Tableau now. That's next week now. So that we say, well, let us wrap up. But if we wrap up, maybe we can introduce Tableau later in the day.
okay, because it's like it's just looking like Greek to some people.
No, because if you are just coming for the first time today, there's no way that this thing will not. It will be very strange. But maybe what you can just do, just try to see what's going on, right? Because, for example, like probability, now if you are learning probability now, this will be the first time you now see the application of where the probability now comes in. Okay. Yes, looking like Greek. Yeah, even me too. It's looking like Greek too. So, but don't worry. So that's why normally you don't advise you to start with R programming first, because starting with R is quite technical, right? It's quite technical. But you can just see what's going on so that you now know, oh, this is where, or this is how they use it in the real world. Okay? Because all this one, we cannot be teaching it in class now. Otherwise, everybody just pack up and leave and say, please, this is not what I signed up for. All right. But for those who are just joining us, just understand that anytime you hear machine learning, so all we are doing, we are building the machine learning model. Okay, so you have your different algorithms that you can use. So just like you see your Netflix, right? You see Netflix, you see your, maybe you see Netflix, you see your Jumia, isn't it? Jumia. So what is doing that? If you watch a particular movie, maybe you picked horror movie, you will notice that because you have watched horror movie, so if you watch horror movie 1, otherwise 0. So because you have watched horror movie, to look for all the horror movies and now start recommending for you, isn't it? It will now show you other horror movie to now recommend horror movies for you. So what is doing that? It will look through your data, through the pattern of what you have been watching. Based on that, it will now help you to what predict. So the back end, this is what you are seeing at the back end. So the same thing that has happened, like on this website now, people who have maybe they have registered, is it not? So they have clicked to purchase, click to purchase, click to purchase. Some did not purchase, some click to purchase. So they now extracted the data out. So they are now asking, what is the chance that this particular person will purchase or not purchase? So that we now know who to target. Okay. So that's exactly what we are trying to see here. So these are what we refer to as what? Your machine learning algorithm. It is when you now bring it to life that it now becomes what? An AI, an artificial intelligence. So that's why they will tell you ML before AI. Because when you now have put it in an app that is now working in real time, that now becomes what? AI. But actually at the back end is your machine learning. So that's what we are just doing here. So this is just the back end of it. So when you hear that data science is the sexiest job, oh, please, there's nothing sexy about it. Oh. It is very annoying sometimes. But it's only when maybe you have gotten to some level now that you start enjoying the money, that's when it becomes a sexy job. Oh. But when you are just starting like this, there's nothing sexy about it. All right, can we go ahead?
Yes, sir.
All right, good. So where were we? Okay, so we have fixed the logistic regression, isn't it? Now, remember that what we want to do, we want to try and see the probability. So if you want to see the probabilities, now what do we do? I can say probability, let's say prob predict. I'll just say predict. So let me always remember to document, is it not? Predicting the test. Okay, let's say test data. Okay. Okay, predicting the probability of the test data. All right, good. So most times it's better you just describe what you are doing. So when somebody picks your code, they can now understand, okay, he's fitting the regression here. Okay, he's checking probability regression here. Okay. Because remember again, another thing you do again is that, see, for most data scientists, right? After you have built your model, so this is what data scientists do, right? Because if you remember how we look at your role as data analyst, right? As data analyst, what are the tasks you normally do as data analyst? What do you do as data analyst?
Data extraction.
You extract the data. What again?
You clean and transform it.
You clean and analyze your data, is it not? What again do you do?
You visualize.
You visualize, is it not? So you build your report, those are your dashboards, is it not? Now, for data scientists now, they will still do up to this point, but now they go further. They can now what? Deploy it. Okay, they can now do what? Deploy it. So that end to end, we say that person is a data scientist. But you see, over time, you now have those that who now specialize in the entire place. So for data scientists now, they will now build machine learning models and now deploy that model. Okay, but the person who is in charge of deploying, right? Most time they will call that person a machine learning engineer. That's the person who is actually, because you know engineers, they are the ones that put this into production. So you see, if you have learned R, most of the machine learning, if you have used R here, when they want to deploy, most time they will still use Python to deploy. So that's why most times it's advised that even if you have learned R, go and learn Python. But if you have learned Python, it's okay. So that's why they will read through it, okay, and understand what you are trying to do here. Then they will now convert what you have done in R into Python before they can start deploying. So that's why there are some people who learn both languages, both R and Python. Okay, but Python is actually mostly for the deployment. You can also deploy in R, but to some extent. To some extent, you can deploy. But when it comes to real-time production, Python is still much better. All right, so let's go. Okay, so now I want to predict, is it not? So we can now predict. We can now what? Predict, is it not? Predict. Now, remember the classifier. So we have predicted the classifier. Predict classifier. Okay. Now, for the prediction, we want to put the response. Okay. We have to now say the type, put it as what? The response. So that our response means, you know that 1 and 0 is our response. Okay. Then we have a new data. What's the new data now? We want to feed it to
It's text.
the what?
Oh, okay. The training.
Test set. It's test set now. That's the new data now.
Yeah.
We have seen it for the train set now, is it not? Now we want to see it for the test set. Now, but remember, which of the variable am I predicting for? Which of these variable am I predicting for?
Purchase.
Purchase, is it not? So it is for purchase, not for all of them. It's just for purchase, is it not? So how do I call purchase out? I want to call purchase now. It will be what? train set what?
Data sets $sign purchase.
Yes, $sign purchase. Is not good. Because if you see that, because that is going to be my response. This is not what I want to predict. But what we are doing here is that for the model, right, we have, let's say, we have age, is it not? We have age and we have what? Salary. Is it not? So remember what we have done here for our train test, we have used this full data to see, is it not? Now what I want to do, I want to predict this one. I want to predict this guy now, right? I want to predict it. So the data has not seen this. So I want to use this data you have seen to now we'll try and predict whether it will give me the same thing. So let me call it Y hat. So this will be the one we predicted, and this is the actual. Then later we'll now compare this actual with what we predicted to now see whether it's the same thing or not. Okay, so which means for me to see these data sets here, I will need to first of all remove those. I need to remove my purchase from there, isn't it? So that I can only see the what, the data itself without the word predictor. Okay, so in that case, I am going to remove the what, the y, which is going to be minus what, 3. You understand what has happened here now, right? So it means give me this data set except this last one. So that means I will use this based on that model to do a prediction whether it's going to purchase or not purchase. Okay, so once I do that prediction, I will now use it to now compare. Okay, you said you are going to predict he purchased. So 0 means what? What does 0 mean? 0 means what? Did not purchase. 1 means what? Purchased. So when I do my prediction, what's the probability that this guy did not purchase? Right? Or what's the probability that he purchased? So whenever you are selecting, 1 is your interest. 1 is your interest. So since 1 is purchased, so you now see the probability that he purchased, probability he purchased, probability he purchased. So let's look at the probability now. So let's run that and check. So if I write predict probability, can you see probability now? Can you see the probability now?
Yes, sir.
So this is what? 0.10. What does that mean now? So look at it now. Look at 2. Is it not? This is 2, is it not? What is probability? What is probability there?
0.0.
So the probability that he purchased is what?
0.01. So that's 1.2%.
About 1.2%. Does that tell you he purchased or he did not purchase?
He did not purchase.
He did not purchase. Look at the next one, 4. So 4, what is the probability that he purchased? What is the probability he purchased?
1%. No.
1%. Can you see that? 5. Now you see he's speaking this randomly. 17. So that's what you are seeing there. Up to what now? 8.
So
Yes, 8. Yes.
can we therefore say that based on, like for example, 4, based on his age, 27 years, and salary of 7,000, probability of purchasing was 0.01.
This one, right?
Yes.
So what it says that yes, based on this, is it not? The probability that he purchased is 0.01. Yes.
Okay.
Remember what he's doing? He's going through your entire data set, looking at the pattern. Is it not? It's looking at the pattern. Because your machine learning algorithm is about pattern recognition. Okay, but take note too that you have done this prediction does not mean it's always correct too. That's why I tell you the likelihood. You know, so for example, there are some cases that you would have actually have purchased, right? But the model will tell you he did not purchase. There are some he will tell you that he did not purchase, right? But the model predicted that he purchased. So what is now telling you, that can also be indicating that even though he did not purchase, right? It will not calculate what is probably that he's likely going to purchase. Actually, he may not have purchased, but it has calculated a high probability that he was going to purchase. That means it can also indicate that based on the pattern I have seen, this guy is likely going to purchase. So then what you now do, they now use it to target those kind of customers. They cannot use that to now target those type of kind of customers because they have the tendency to purchase, but they have not yet purchased. So you can now group those guys and now do a target marketing to them. I don't know if that makes sense.
Yeah, yes.
Okay, good. All right, so these are the probabilities now, right? So because most time probability may look scary now, so let's just convert it now to numbers. So 0 and 1. Let's convert it to 0 and 1. Where 1 means what you purchase, 0 means you did not purchase, isn't it? So we can say, let's say Y pred. Let's say if else. So if what now? If this my probability pred is greater than or equals to what? 0.5. Assign what? 1. Otherwise, assign what? 0. Is that not it? I think this is what we have now. If I want to attach it on the data set now, I can now put this one. What's the name of data set? What's this data set now?
Tests, training set, training set.
Okay, training set, right? So let me call it Y. Let me call Y. Let me assign Y to what? Training sets. So if I say view Y, let me see, view Y. I just want to use to test something. I want to use to just test. Okay, I want to use to test. Okay, so this is purchase. This is not purchase. So here, what I can now do, I can now assign it to where now? So this thing that I've run here now. You see that? So I want to assign it now to where now? Y. So let me call it what? Y pred. Can you see that now? So let me view Y now. Can you see it now? So this purchase was Y. So you see this one, he correctly predicted this one did not purchase. But you see this guy purchased, but he predicted he did not purchase. This guy did not purchase, but he predicted he purchased. So what we are saying that most times what people now do is that because he has shown the chance, so if we check, we'll see some, he may predict it correctly, some may not predict correctly, some may be correct, some may not be correct. Can you see that? So that's why most time, once you see your model, you see like this one now, predicted you buy and he actually bought. So there's always a chance that it may be correct, may not be correct. So what people now do is that based on these ones now, you see they have not yet purchased. Can you see they have not purchased? But it predicted that they have purchased. Can you see that? It had predicted they had purchased. So they will now target these ones. They will now target these ones. That way it predicted he has purchased and go and what? Do marketing to these people. Because based on the model, it's showing the chance of them what? Buying it. Okay, so that's what again some can also do. So that's how you can also do it. So that's to check between 1 and 0. Alternatively, I can have done it this way. Let's say predicted purchase. So I say if it's greater than or equals to 1, call it what? Likely purchase. Likely purchase. Why this one? Call it what? Not likely to purchase. Not likely to purchase. All right, so let's run that and let's view it again. Can you see what has happened now? So can you see not likely to purchase, not likely to purchase, not likely to purchase? Can you see that now? So I can now assign it like this. Can you see that now? So likely to purchase, we can now target them. So if I had now put the probability there, so let's say, for example, where's probability? Where was the probability? Okay, let me assign the probability now. Okay, where was it here? Okay, so let me do that for this. So let me put probability now. Y probability. Let's run that and check. Now, can you see that now? So let us assign it. So can you see this guy? So if I now come here to the highest probabilities, can you see that? I'll now check, okay, this one shows 99% is likely to buy, but actually he did not buy. Can you see that? So there's a tendency that he may actually come and buy. So those are not guys you can now target to buy. Can you see it now? So you can now set a benchmark. Those ones that are maybe 80% and above, those are the people you target. So these ones, for example, these guys actually purchased. So we can leave those ones out. But the ones who have not yet purchased, but are showed 90%, now those are the guys who can now target. So can you see how you can now use machine learning now to now target certain clients?
Okay, yeah.
Yeah?
Yeah.
And that's why probability is very important. Okay? So that's why your probability is very important. I'm sure this is clear now, right?
Yes, it is.
Okay, good. So once you have done that, the next thing to do is to check your, you do what they call your confusion matrix. Confusion matrix. You know, for your confusion matrix, what you are actually trying to do is that's my actual Y, is it not? You now predict, you now have the one you predicted. Is it not? So this one will be in your test set. Is it not? The one that was the actual, right? This one is the one you are predicted. So you are now checking, did it correctly was predicted? So we'll say, for example, 0. So this may be your predict. So let's say predicted. 0 means did not buy. 1 means he bought. 0 did not buy. 1 means he bought. Is it not? So this is actual. This is what you have in your actual data. So he did not buy. Actually, he bought. Or this is not purchased. This is purchased. Not purchased. This is what purchased. Okay. So what we are checking is that he did not purchase. The model predicted he purchased. He purchased. The model predicted he purchased. So that's why actually you are looking at what? This part. Because that's what's the most important for you. Okay. That's most important for you. Then you can now divide it by the total amount to now know your accuracy. All right, so let's run our, and that's one thing, because it's not about the programming language, it's the step. Even whether I use Python or R, you see that it's the same step we are doing, only that we are using different language to write it out, but it's actually the same thing we are trying to do. Okay. So if I want to do my confusion matrix, let's say confusion matrix. So I'll put it in a table so I can really read it. So I can say test sets. Now test set, remember it was purchased, is it not? Test set purchase. And my Y preds, is it not? So I'll put it in form of a table. So let's see. So what has happened here? So what can we see here now?
Just giving us the.
So what is the total here? What's the total here?
So how did you pick Y-Pred for only purchase when you did not specify that you should pick only purchase?
No, you see that Y-Pred, there's breaking them into two now, 0 and 1 now. Actual 0 and 1.
Okay.
You see that? This is the actual. This is the Y predict, the one you predicted.
Okay. Y-Pred is the column. Is the column inside the.
Yes, now look at it now. You know, when I did my prediction, I called it Y-pred here.
Yes.
Can you see that?
Yes.
So that if it's greater than 50%, give me 1, otherwise 0.
Okay.
So that's exactly what we have done here. Look at, if you remember our data sets, this is what we have before. Where was that my Y? Hey, look at it here now. So this is what we had before now, isn't it?
Yes.
So I now change it now. Instead of leaving it as probability. So where the probability is greater than 50%, assign 1. So I can easily match with this. Can you see that? So I can easily match it with this. So in the test set now, this is what we have predicted. Can you see that? In the test set, this is what we have now predicted. Okay, this is what we have now predicted. So we'll now use that to check.
Okay.
All right. Okay, let's go. That's clear, right? So what we are seeing here now is that actually 44 did not buy, is it not? 44 actually did not buy. He predicted that what? They did not buy. So 44 of them correctly predicted it. Why these ones, right? They purchased. And he predicted actually they purchased. They were 20. Can you see that? Because if I look at my entire sample size, so how will I check the sample size now? So if I check my test set, how do I check my test set now? I can use what? Okay, if I use, okay, let's use Glimpse. Glimpse. So can you see how many? I have 80, is it not? My sample size is 80, there, is it not? 80. So if I add it up now, how many would that give me? 44 plus 47 is plus 7 is what?
44 plus 7 is 51.
44 plus 7 is 51, is it not?
Yeah.
Plus 9 plus 20. What would that give us now?
8.
That will give us 80, is it not? That will give us 80. So 44. So 44 plus 20, what is that? 64, is it not? So 64 divided by 80. What would that give us?
80%.
So that means our accuracy, our prediction, model accuracy is what?
80%.
80%. Can you see that now? It's 80%. Now the question now is 80% good enough for you? If you still say no, it's not good enough, that means I can go and either add more variables or increase the data set to just check. Okay? Or you just increase the data set or increase more features to it. But if 80% is okay, then I can now go and what? Deploy this one. Because sometimes you will try. So when you look at those Kaggle competitions, I think we have shown you Kaggle competitions, right?
Yeah.
You see how they will now check, oh, the accuracy. You even see that sometimes the highest person may be 80 or 85, right? But the more features you add, the more accurate it is. But you see, it's not enough to just be putting features. You must have a way to explain why. So explainability is another issue again, isn't it? So it does not make sense. For example, if I had gone to put maybe like the employee ID inside the model and it predicted 100%, how does employee ID explain the likelihood? So in that case, it may not be explainable, but it shows you a high prediction. So what they consider is accuracy and explainability of your model. All right, so this is about logistic regression. I hope this is okay.
Yes.
Okay, so let's quickly look at another model. So assuming the same data set now, we want to do KNN. KNN. So KNN. KNN is what?
Nearest neighbor.
Nearest neighbor. And this K nearest neighbor, what is he trying to explain? It's trying to look at your data set, isn't it? So you have the ones that purchase, the ones that did not purchase. right? So I can have maybe purchased, not purchased, purchased, not purchased, purchased, not purchased, purchased, is it not? Purchased, 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 purchased. Can you see that? So if I bring a new data, if I bring a new data point now here, right? What's the probability that, how will it classify? Will it classify it as not purchased or will it classify it as purchased? Based on what I have here now.
Not purchased because it's closer to not purchased. No, which one is purchased on top?
This
right?
is purchased. This is not purchased.
Okay, to put as purchased because it's closer to.
So it is because it's closer to this, is it not? It's closer to this, is it not? So because I'm just using just 2 here, this my k is equals to 2. Can you see that? My 2 nearest, this means my 2 nearest neighbor. If I say k is equals to 5, so I will count the first 5. 1, 2, 3, 4, 5. So I'm looking at it based on these 5. Can you see that? So based on these 5, this point now, how will I classify it? Purchased or not purchased?
I still classify it as purchased.
And it will still classify it as what? Purchased. That's it. So that's what they call k nearest neighbor. Do we get that? K nearest neighbor. Okay. So that is exactly what it is. So it's also what a classification what algorithm. Okay. It's also to help you what do your classifications. All right. So the same way. So remember how we brought in our data. So can we use the same procedure? So let's get our. Let me get my data set. Up to this point, you see, up to this point, all of them will be the same thing. K nearest neighbor. So up to this point, you see they are all going to be the same thing, right? So the same way I can bring in my data sets. So let me bring in my data sets. So let's say import data sets. Okay. So I'm importing my data sets there. Then I'm selecting the variables I need, is it not? I am setting seed, but if I don't set seed, you see the same thing, it doesn't really matter. Then split, right? I will train, I will test. I will train, I will test. I will now scale. Can you see that? I will now scale. Okay. Now I'm ready now. So once I've scaled, what's the next step now after scaling? After scaling, now what's the next thing?
Fit your model.
You fit your model exactly. After scaling, you what? Fit your what? Model. Now, but take note, in order to run your KNN, to fit your model, there's a library we are going to bring in. And that library is called class for KNN. So I'm not sure we have talked about this. Okay. We are not talking. You see, for logistics, we had used what? GLM, is it not? So that will fall under your normal CAD tools. But you can also bring another one called class. Okay, class. If it does not work, you will not need to install it now, is it not? So I will say what? Install what? Dot packages. Then call class. Then run it. Okay. Otherwise, if you have run it before, so I can just put that there. Class. Then I will install the package. Okay. So now if I want to run fit my model now, so I'll say, let's say ypreds KNN. I'll now use KNN. Okay. So I'll say my train sets, my train what? Training sets. Now my training sets, I want to use all of them except that's what? My target variable, is it not? My test set will be the same thing. Anything you do for train, do for test, is it not? So my test sets will be what? Everything, is it not? All my rules except my what? Target variable. Is it not? Then I will now use my classifier, because what I want is now what? To use the training sets. Now, but for the training set, I'm going to use all the variables here. Okay, so that you can go through data, right? Then by default, my K, I can either use, so that's your K that I explained there, is not my K nearest neighbor. I can use 2, I can use 3, I can use 4, but preferably use what? An odd number. You know why I should use an odd number? You know why I should use an odd number? If I have, for example, 1, 2, 3, 4, can you see that? Now, if I use K as 2, if I use K as 2, maybe it's in between here. Can you see that? If I choose, let's say, K as 2 between here now, how will I know which one is there? But if I had used 3, if I use 3 now, can you see that? It can now say, okay, this is more, because this one is more and it's closer to this, is more likely to be this guy. So that's why most times, preferably, you use what? An odd number. Your K should be an odd number. So you can use 3, you can use 5, you can use 7, you can use 11. Can you see that? You can use 13, but most time default, they usually use 5. But you can keep adjusting it, keep adjusting till you get the best that you want. But default, you can just use 5 there. I hope that is okay. So let me bring it out so that you can see what's going on there. So the test sets. Can we see that now? Because if you remember again, if I want to read it now, if I say KNN, you see K nearest classification. Can you see that? You can now read it. So you see everything there, factor of true classification. Okay, you just read through, you see examples. Can you see that? They'll give you examples there. You can copy and use their own example that way. But if you want to use their own. So let's run it and check. What did he say? Unexpected what symbol where? Hope I don't mix anything now. So what did he say? Unexpected symbol in where now? Widespread. Okay, let's see what happened. Okay, train. Okay, train is equals to test will be equal to. That what it give me the okay, train test. Okay, train test. Let's run that and check. All right, good. So if I run widespread, can you see that that's classified it now? Remember that 0 and 1, 0 and 1 that we did before, isn't it? It has now classified its own. Okay, so what's the next step after doing your own? What's the next step? After doing your prediction, now what's the next step?
Now find the probability.
Yes, if you want to find the probability, but in this case, because it's a classifier, right? You just only group them. If you want the probability, that's fine, but most of the probability you are going to get is just to classify them, right? So again, you just see, for example, when we did for what they call it now, for logistic regression, where was it now? Logistic regression. So you see what we have done here at this point, where we are doing this widespread, is it not? So we now classified into 1 and what? 0. 1 and 0. Okay, 1 and 0. Probability prediction, will that work for KNN? Because you have to now look for KNN way of, because of the library, it will not follow this one. So if I want to learn it now, I have to now come to this place. Now type, for example, probability for KNN. So if it's there to show you, otherwise, just go and go. If you cannot see it there, then just go on Google, type it there. Can you see probability here? So it's prob, because zone prob. So if this is true, proportion of the votes. Can you see that? So that's probability there. Again, if you want to check this, you can always click on it and go and read through. Okay. So next thing we can do now, let us do our, what they call it now? Confusion matrix. Where's our confusion matrix? All right, let's check confusion matrix. So let me copy that. So you see, every step will just be similar up to the point of the classification. So this is confusion matrix. Okay. Now, is it the same thing now? So we have our what? Y-pred. Okay. Should I call it confusion matrix 1? Or should I leave it as the same thing? Which one should we use?
Same thing. We already use Y-pred.
Should I use the same thing?
Yes.
Okay. Now, this one now, watch what will happen now. Before we predicted how many, let me see how many we predicted correctly. Okay, this one was 20. So the first one we did was 44. The first one we had done was what? 44 what? 20. This one now predicted 44 what? 25. So this is 69. So 69 over 80, what would that give us? This is 86. This, so which is more accurate now in this prediction? Logistic or KNN?
KNN. What? I didn't see the 25. I didn't see how.
Okay, the 25.
Yes.
Okay, you know that, for example, if I put this here, let me.
Okay, it didn't come out under it. It came out in the.
Yes, if you want me to, unless you want me to put it in the table for you. If I put it in the table, that's where you will see it. So, you know, for example, here, where's my test? This is my test set, right? Test set. So if I say view test sets, you know this is view test set, is it not? So I want to now put the predicted, because this is the actual, is it not? So I want to put the predicted now. Okay. So let me put the predicted. Where was I? Uh, 29. Okay, good. So let me call it under what now? So view test set. So let's say test sets. Let me now say prediction. Then I can now paste it there. You know what I've done now, is it not? The prediction now, I want to assign it now. That 1 and 0, I want to assign it to that prediction now. So let us see it. Can you see that? So let me view my test set now. So can you see prediction now?
Yeah.
Can you see prediction now?
Yeah.
So he purchased, he predicted did not purchase. Did not purchase, but predicted did not purchase. Did not purchase, did not purchase. Purchase, 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 purchase. You know, purchase, predicted did not purchase. So by the time I check through, can you see that? By the time I check through, you see that it's actually much more accurate, right? Can you see that now? So that's it now. So that was where it predicted it. Is that clear?
Yeah, it's making sense.
Okay, good. So that's okay, but that's it now. So that's for KNN, right? That's for KNN. Which other one did we say we'll look at? Okay, if you want to look at vectors, vector. That's vector support machine, isn't it? Now, vector support machine is almost like vector support machine tool is almost like what that one, but it's also classifying it, right? It's also classifying it. Let's say 0, 0, 0. So it's like putting a line. That line is what they call a support. So the ones that captured it as close as possible to separate it. Okay, so what it's doing is trying to classify them. So you put a underline again to check which one will capture the best. You put underline again. So the one that will get what the best. So that's what the support vector machine is about. It's also what a classifier. Okay, so let's call it support vector machine. You see, that's why if I'm not gone, remember, I think I've gone through almost all the algorithms, is it not? There was one session where I explained almost all the algorithms. I don't know, on that Excel sheet, did you indicate it? There was one particular class where we did just the theories behind it to explain everything about them.
So
that you can go there.
It was in Python when we were doing the.
Okay, was in Python?
Yes.
Okay, well, in Python, okay. If I explain most of them theoretically so that you can go back and look through that video. All right. Okay, so let's go. So we are going to see now support vector machine. Now, the first step, the same way, we first of all import our data. So let me just go and get.
So for the explanation, I think it's the last two classes for machine learning, 24th and 31st or so.
The last two classes, right?
Yeah.
Okay.
1st and 24th of July.
Okay. So let's copy that. So that when you get back, you can, so if you are used to Python already, you can still see how you do the R version of it. So you can do Python, do R, and see whether they will give you the same result or different. So the same way, import the data, select my data set, isn't it? You can use set seed if you want. Now, even the split, if you want to use 80%, you can use 80%. You can select 75%, feature scaling. Now, there's something I wanted to add. Oh, I just forgot. Now, you see, for this particular vector machine, because there's this thing that you're going to use, that these tools, these CAD tools, right? For support vector machine, that's why you need these CAD tools. Okay, but there's something that it does that is a bit different from what we have been doing before. Where is K nearest neighbor? Okay, let's start it from here. So for support vector machine, right? So we first of all import the data set. Is it not? We'll select the data set, right? Okay. Now, but once you have collected the data set, now there's something you need to also do, right? You need to convert it. You know this is your variable here. This is your purchase, right? It's normally 101010. Okay. But because it's a classifier, you need to change that your data type. So this way is a bit different. Because if it was Python, you are running it straight, it will work straight for you. But here you need to convert that particular variable purchase into a nominal. You know what nominal data is, right? Nominal. So I will change it now. Nominal. Okay. So I'll convert it into 0 and 1, which you call levels. At levels. Okay. So I have to convert it to what? These levels. So that levels means that I'm explaining that is a what? Categorical what? Variable. Okay. Or as a factor. So what we will now do, we need to now specify it there. For the other ones, we don't need to always need to do this. But for this particular one, we must do it. For this one, a naive neighbor, we must also do it. So let's say, for example, so data sets purchased, right? So we'll now change it to a factor. Okay, so data sets what? Data sets purchased. Okay, I need to call it levels. And levels, I'll put 0 and 1. So what I've done is that I'll set it as a factor. Because if you don't do it as a factor like this, then it's going to be giving you errors. So we have to set it as a factor. Okay. Then again, what we also need to do is that when you are running it, you now need to bring in the tool, that's your library. So cat tools, but not because we have brought it before, but you need to bring it when you are running it. Okay. Then let me set this. Okay. Then the same procedure. I don't necessarily need to view it, but if you have to view it, you can view it there. Okay. Now the next thing I want to do, I want to split it, is it not? I want to split it. So the same splitting, the same way we have been doing the other one. So I'll split it, train, test, feature scaling, train, test. Okay. So now after I've done my training and test, and that library again that we need to bring, because this is a bit different from so another library I will need to also bring is what they call it. There's this library called, what's that mean? What's the library? Is it 1020 or 1071? Is it 1071? No, E1070. I think it's E1071. Yes, E1071. Now, otherwise, if it doesn't work, you need to install it. Install packages E1071. So if I put question mark E1071, it's like this one does not have any documentation. E1071, no documentation yet. Okay, but if I run it here, right, it has worked there. So, but you have to install it. So to run your so I need, let me call it classifier. Okay, so SVM. So what's my formula? Formula is what? Purchased. Is it not? Now I'll put my full stop to bring every other thing, comma. What's my data? My data will be what? Training sets, comma. What's the type? What's the type? Now you have what they call C classification. There's a classifier, classification. Please take notes, take notes, take notes. You see this classification here? So let me bring it down so that you can see what we are doing here. You see this classification? It must be lower C, because if you're going to make mistake and put capital letter C, error. And you can look for that error, you will not find it. So take note of that. Okay. Then we now have another thing called kernel. Okay. That one will just use our normal linear notes. If you have other this, you can also other model, you can also do that. Because for your SVM, there are two types. So the reason why we do that is for SVM, we can have two types of classification. We can have our regression. So you can have SVM regression, or you can have SVM classification. But because this is a classification case, that's why we're using C classification. Otherwise, we can use for regression. So there's the regression and there's classification. So because this is a classification, that's why we are using the classification. Yeah.
In practice, are we supposed to, like, for a single data set, use the different algorithms, or do we just pick one algorithm and play with the different?
No, it is better. It is most time it is better you choose several, because of that no free lunch theory. Now, one can give you 90% and you're okay with it. Do you get? But assuming that algorithm can give you 98%, which would be better, 98 or 90, which would be better? 98. So that's why, as long as they can predict it, that's why they say use the different algorithms and choose the one that gives you the best prediction. So that's why if you are just use one and it gave you 90%, you're okay with it. As long as the prediction makes sense. Okay? You can go ahead and still use one. However, most time you see them, they still keep applying different algorithms. But you see, when you choose one, when you want to now deploy, it is that particular one you have chosen that you now use to deploy. Do you understand? So if I have used one and it was 90%, and all the other ones, if I had used it before, it would have given me 80%. It still makes no difference. I'll still use the one of 90%. But when I'm deploying, it is just that one that gives me the best I will deploy. So at the end of the day, it's still one I will use. But it's just to check and confirm that of all the ones I have, this is the one that's the best. I don't know if that answers you.
Yes.
All right, good. So the next thing we want to do our prediction, is it not? Prediction. So Y-pred. I'll say predict. So what am I predicting? This classifier, right? Since an object classifier. Predicts classifier. My new data. So what's my new data? It will be my what? Test set, isn't it? Test sets. I'll remove that. So let's, if I run Y-pred, now if I want to, because now this one is just like your, what do you call it now? It's just like your other one. So if I want to now convert them into 0 and 1, what do I do? If I want to convert them into 0 and 1, what do I do? I can say what? If else, what? If Y-pred is greater than or equals to 0.5, is it not? Give it 1, otherwise 0. So if I say Y-pred, can you see that now? So which one do you prefer?
But there were some negative numbers in the original Y-pred.
Which negative number? No, you know when you scale it, that one is scaling.
Okay.
That's because of scaling, but you still look at it. Don't forget now. It's not matching it number for number. It's matching it pattern for pattern. So it's not the absolute number it's looking for, but the pattern that it's looking at. Okay. So that means in this case, if I want to build my confusion matrix, so I say table, so my test set, then we have what? Y-pred. So let's see this. Aha. That first one, the second one we have done, it gave us what? This 69, is it not? So the first one we had was what?
64.
So let me be copying all of them together. Okay, now, so let's see. So logistic, was logistic, is it not? Logistic. This one was what? This one was what?
KNN.
KNN. KNN. Which other one now?
SVM.
This SVM now. So SVM now is what now? So this is what?
45.
45 plus what? 17. That gave us what? 62. So 62 divided by 80, what would that give us? 77. This one is 77. So far, which is still the best?
KNN.
KNN is still the best, isn't it? All right. Now let's do the another one. So which one is now? Okay, naive B. Okay, let's do the last one. Naive B's. Okay, naive B's. So for naive B's, almost the same procedure. Almost the same procedure. So let me copy it from here. So up to scaling, you see, up to scaling, all of them will be the same thing. Copy. All right, so let's see it. So I've imported my data set. Now you see my purchase now, right? I have to also set it as a factor, right? At levels, I'll do the same thing at levels, okay? Now, what we are going to also see is that when you are now running your, what do you call it now? So the library cat2, so now we can also set the data set, right? Set it, split, training set, test set, right? I can now scale. Okay, good. So now I have scaled, is it not? I've done all my scaling, okay? Now, and that thing again, my library, and that library again, I'm going to use for this one. It's just the same way with that particular one. So I still need this library too. I will still need this library. So that library is what? E1071. So I'll still use the same library. And library E1071. Okay, so if I have classifier, so let me use the same classifier. Okay, so in this case, I'm using naive B. Naive B. Now take note how it's spelled to. You see the B is capital letter. Because otherwise you try and try and try, you're getting error. So training. So I have training sets. So I'll remove that one. For my Y, I'll call training sets, which is what going to be what purchased, is it not? You can run that. Then now next introduce to do what prediction. Prediction. Okay. So if I have Y pred, so I have Y what pred. Now in this case I have predict what the classifier. So you see it's almost the same thing like what we have done before. New data will be what now? Test sets. Test set that. So Y preds. Can you see that 1010? So what's the next thing to do? What's the next thing I'll do now? What's the next step now? So build your classification confusion matrix, you know, table. Now, what's it? Test set, right? Test.
So I didn't do the probability. Okay, we didn't do the probability. Okay.
Okay, this one had already converted already for me.
Okay.
This one had converted it straight for me. Some they will use predict, but some will convert it straight for you. Now, most of the ones that are classifiers, right? They will just take it straight as 1 and 0. They will not convert it into probability. Okay, so let's do that. So that's the last one here. Y preds. Y preds. So let's. So. So this is what 4581. Let's check the last one we have done. So let's see. So for what now? This one is what now?
Naive Bayes.
This is naive Bayes, isn't it? Naive Bayes. All right. So for naive Bayes, we now have what? 45 plus what? 21. All that gives us 66. So we now have 66 divided by 80, 82. So this is what? 82%. So this is 82%. Logistic. So far, which one was the highest now?
Yeah.
KNN. So the best method
KNN.
the best we'll now use is what? The KNN. So you see, if from the beginning I had just used KNN, I can use KNN throughout. Can you see that now? Because still one you can only use at a time when you want to deploy. All right, so that's why we'll now use what? KNN. All right, ladies and gentlemen, I think we have come to the end of our.
Wow.
Okay, so by next week, we should start our, what they call it now? We'll start with Tableau. Okay, so make sure you try and download what we already download your software, the Tableau, right? Most times you have the free version, but I don't know if you check, because they also have Tableau. Is it professional? You also have your Tableau Professional too, but if you can have Tableau, for those who have been using Tableau, if you have maybe in your organization they have Professional and subscribed already, you can also use that. But otherwise, if not, you can just use the free version. Okay, but the free version is a bit limited, so that's the only thing. But we'll start with Tableau next week, so we can start doing data visualizations. All right.
Okay.
All right.
Thank you so much, sir.
All right. You see this R, please make sure you practice it. Otherwise, you look like miracle. All right.
Okay, sir.
All right. So I'll see you guys next week. All right. Take care.
Thank you, sir.
All right. Bye. Yeah,
Bye-bye.
take care. Bye.